Thermostat cycle rate. I'm sure you're asking yourself, what is a thermostat cycle rate? Why is a thermostat cycle rate important? What is a cycle? And what thermostat cycle rate should I use? First, we need to define what a cycle is. A cycle is defined as the unit off time plus the unit on time. Why is the cycle important to us? If we set the cycle rate properly to match the equipment, the system will operate in a manner that will keep the space temperature constant and comfortable for the occupants and help efficient equipment operation. Let's compare two cycle rates, a slower cycle rate and a faster cycle rate. When it comes to temperature control, the slower cycle rate has a wider temperature swing and a faster cycle rate has a tighter temperature swing. As noted earlier, a cycle rate is defined as the unit on time plus the unit off time. So a slower cycle rate will have longer on-off times, while the faster cycle rate will have shorter on-off times. What does that mean for comfort? Remember, the human body can pick up on a temperature change of around 2 to 3 degrees Fahrenheit. The slower cycle rate, if selected for the wrong system, can cause reduced comfort due to longer on-off cycles and wider temperature swings. Where the faster cycle rate, if selected for the wrong system, can cause shorter cycling of the equipment, creating loss in efficiency. Selecting the correct cycle rate for the system being installed is a very important step that every installer and service technician should be aware of. In this example, we will look at a system that has a thermostat set temperature of 70 degrees Fahrenheit. With a 2-degree differential, the thermostat will cut in at 69 degrees and cut out at 71 degrees. If we set the thermostat cycles per hour to 2, the system will cycle on twice per hour, as shown here. Now we have a thermostat that has a 0.5 degree differential and is set to 6 cycles per hour. You can see the peaks and valleys in the temperature and how often the system will turn on and off. This can lead to less efficient operation of certain systems, for example, a heat pump. When a heat pump compressor first starts, it is not efficient. It takes a few minutes to become efficient, and with a fast cycle rate, you can see the unit will turn off before the compressor reaches peak efficiency. This thermostat turns on the compressor and allows it to operate for about 5 minutes, and then turns it off. The compressor did not run long in peak efficiency range. Today's digital thermostats come factory preset with cycle rates. Some thermostats have slow, medium, and fast cycle rate options. Others have numbered cycle rates per hour. As seen here, one cycle rate does not fit all systems. The list shown is what most systems would want the cycle rates to be set to. However, climate and building conditions can play a factor in the settings, and minor adjustments may be needed after setup for the end user. A quick note about cycle rates. The only time you will see the system cycle at exactly the cycle rate programmed on the thermostat will be when the following conditions are met. The heat loss of the structure is equal to 50% of the BTU output of the heating unit. In conclusion, setting cycle rates properly will increase comfort, increase efficiency, increase the life of the equipment, and is not one setting fits all.